Good morning, my dear students. Welcome to our discussion for today. Today, we will be illustrating inequalities in one triangle. Once again, I am teacher Joanna C. Estelione. To illustrate inequalities in one triangle, we have the following theorems. The first theorem is exterior angle inequality theorem. It states that the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Its measure is equal to the sum of the two remote interior angles. So we have there the illustration of a triangle with angle D as the exterior angle and angle A and B as the remote interior angles. So when we say exterior angle, this is an angle formed by one side of the triangle and the extension of an adjacent side of the triangle. While when we say remote interior angles, these are the angles that do not share a vertex of a triangle with the exterior angle. So in this illustration, we can say that angle D, or the measurement of angle D, is greater than the measurement of angle A and angle B, while the measurement or the sum of the measurements of angle A and B is equal to the measurement of angle D. So let's have this example. Find the measurement of angle A. So we have there a triangle ABC with angle BCT as the exterior angle. Angle B and angle A are the remote interior angles. Angle B measures 60 degrees. So to find the measurement of angle A, we will use the exterior angle inequality theorem. So we know that the sum of the measurements of the remote interior angles is equal to the measurement of the exterior angle. So we have now the measurement of angle A plus 60 degrees is equal to 120 degrees. By addition property of equality, we have now the measurement of angle A is equal to 120 degrees minus 60 degrees. So we subtract them, then we have the measurement of angle A, which is 60 degrees. So to check if the measurement of angle A that we obtained is correct, we are going to add the measurements of the two remote interior angles. It should be equal to the measurement of the exterior angle. So we add the measurement of the two remote interior angles. So 60 degrees plus 60 degrees is equal to 120 degrees. Therefore, the sum of the measurements of the remote interior angles is equal to the measurements of the exterior angle. So, the measurement that we obtained for angle A is correct. That's all for exterior angle inequality theorem. Now let's move on to triangle inequality theorem. It states that the sum of lengths of two sides of the triangle will always be greater than the length of the third side. This rule is satisfied by all the three sides of the triangle. It means if we have the lengths of the two sides, we can safely bet that the length of the third side will be smaller than the sum of the two sides. So to understand further triangle inequality theorem, let's have the following theorems. The first theorem will be triangle inequality theorem 1. It states that if two sides of a triangle are unequal, then the angles opposite these sides are unequal. The angle opposite the longer side is larger than the angle opposite the shorter side. So let's have this illustration of a triangle ABC with sides AB, BC, and AC. If side AB is greater than to side BC, then angle C is greater than to angle A. If side AC is greater than to side AB, then angle B is greater than to angle C. If side AC is greater than to side BC, then angle B is greater than to angle A. So before we proceed, class, I want you to know that the side opposite or the angle opposite to side AB is angle C. And the side or the angle opposite to side AC is angle B. And the angle opposite to side BC is angle A. Next. So if side AB is not equal to side BC, then angle C is not equal to angle A. If side AC is not equal to side AB, then angle B is not equal to angle C. If side AC is not equal to side BC, then angle B is not equal to angle A. Let's take this example. In triangle ABC, side AC is equal to 31 millimeters. Side BC is equal to 35 millimeters. And side AB is equal to 5 millimeters. What is the largest angle? Okay, so first, we determine the opposite angles of each side. So side AB, or the angle opposite to side AB is angle C. Side AB is the shortest side. Next, the angle opposite to side AC is, or the angle opposite to side AC, I repeat, is angle B. And the angle opposite to side BC is angle A. What is the longest side? The longest side is side BC. Therefore, the largest angle should be side or angle A because it is the angle opposite of the longest side, which is side BC. Next, we have triangle inequality theorem 2. It says that if two angles of a triangle are unequal, then the sides opposite these angles are unequal. The side opposite the larger angle is longer than the side opposite the smaller angle. So we have there a triangle MON with sides MO, ON, and MN. The angle opposite to side MO is angle N. And the angle opposite to side MN is angle O. The angle opposite to side ON is angle M. If angle M is greater than to angle N, then side ON is greater than to side MO. If angle N is greater than to angle O rather, then side MO is greater than to side MN. If angle O is greater than to angle M, then side MN is greater than to side ON. And if angle M is not equal to angle N, then side ON is not equal to side MO. If angle N is not equal to angle O, then side MO is not equal to side MN. If angle O is not equal to angle M, then side MN is not equal to side ON. Now let's have the third example. In the figure, triangle MON, measurement of angle MON is equal to 110 degrees. The measurement of angle OMQ is equal to 145 degrees. And side OM is equal to side ON. Now, what is the measure of angle ONM? What is the measure of angle POM? And what is the longest side of triangle MON? Okay, so let's find out. For letter A, we determine the measure of angle ONM. So given angle OMQ, so OMQ and angle MON, or the measurement of this angle. So the measurement of angle OMQ is 145 degrees. The measurement of angle MON is 110 degrees. So we can find the measurement of angle ONM by exterior angle inequality theorem. So angle OMQ is the exterior angle, and angle MON and angle ONM are the remote interior angles. So we can say that the sum of the measurements of these two remote interior angles is equal to the measurement of the exterior angle. Okay, so we have now the measurement of angle ONM plus 110 degrees is equal to 145 degrees. Then by addition property of equality, we have now the measurement of angle ONM is equal to 145 degrees minus 110 degrees. Then we subtract it, so we can say, or we can determine that, or we obtain the measurement of angle ONM is equal to 35 degrees. Okay, next for letter B, we find the measure of angle POM. So angle POM and angle MON are supplementary angles. Therefore, we can subtract angle or the measurement of angle MON from 180 degrees. Okay, so we have there 180 degrees minus 110 degrees. Okay, so we subtract it. Therefore, the measurement of angle POM is equal to 70 degrees. Next, we are going to determine the longest side of the given triangle. Okay, so in this triangle, the largest angle is angle MON. And the opposite of, or the side opposite of angle MON is side MN. Therefore, the longest side is side MN. Okay? Next theorem, we have triangle inequality theorem 3. It says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so we have there a triangle with sides X, Y, and Z. It says that if we add the lengths of the two sides, it should be greater than the measurement of the third side. Okay, I repeat. If we add the measurements of the two sides of the triangle, it should be greater than the measurement of the third side. Okay, so let's have example number 4. If 5 centimeters, 9 centimeters, and 3 centimeters are the measures of 3 line segments, can it be used to form a triangle? Okay, so the triangle is formed by 3 line segments, 5 centimeters, 9 centimeters, and 3 centimeters. Thus, it should satisfy the triangle inequality theorem 3. Okay, so let's check. So if we add the measurements of the 2 line segments, like for example, we have 5 centimeters and 9 centimeters. If we add them, we have 14 centimeters. 14 centimeters is greater than 3 centimeters, so it is true. Then if we add the measurements of the 2 line segments, we have 9 centimeters and 3 centimeters. We have 12 centimeters, and it is greater than 5 centimeters. It is true. But if we add 5 centimeters and 3 centimeters, it is 8 centimeters. 8 centimeters is not equal or 8 centimeters is less than 9 centimeters. Therefore, it is false. So the assumed sides of the triangle do not satisfy the inequality theorem. So we cannot construct a triangle with these 3 line segments. Okay, next example. Could a triangle have side lengths of 6 centimeters, 6 centimeters, 7 centimeters, and 5 centimeters? And repeat, could a triangle have side lengths of 6 centimeters, 7 centimeters, and 5 centimeters? So if 6 centimeters, 7 centimeters, and 5 centimeters are the sides of the triangle, then they should satisfy triangle inequality theorem 3. Okay, so let's check. So if we add the two sides of the triangle, we have 6 centimeters plus 7 centimeters. We have 13 centimeters. And it is greater than 5 centimeters. So true. If we add 7 centimeters and 5 centimeters, we have 12 centimeters. And it is greater than 6 centimeters. It is true. If we add 6 centimeters and 5 centimeters, we have 11 centimeters. And it is greater than 7 centimeters. So it is true. So all the 3 conditions are satisfied. Therefore, a triangle could have side lengths of 6 centimeters, 7 centimeters, and 5 centimeters. Okay, so that's all for inequalities in one triangle. So once again, my dear students, I am teacher Joanna saying that if you can imagine it, you can achieve it. If you can dream it, you can become it. Thank you very much for watching, my dear students. Have a nice day.